Hi guys, this is the video for Chapter 8, Lesson 6. So in our last lesson, Chapter 8, Lesson 4, we talked about how to find the rate of change of something. And so today we're skipping Lesson 5 and coming to this lesson because I think those two kind of, Lesson 4 and Lesson 6 go together better. Lesson 5 is kind of stuck in there, and so we'll come back to that next time, but we're going to go over this lesson first. So if we want to review a little bit, in our last lesson, we talked about finding the rate of change. And so the rate of change is really looking at how fast or slow something is changing as an increase or a decrease in some type of situation where we're comparing two values, right? Or maybe it's time and money, or it's speed and time. So we're looking at the rate of change that something happens. And so what we're going to look at today is slope, which is really essentially the same thing, but slope doesn't necessarily have to relate to, I guess, real life situations where you're looking at, two values compared to each other, like time and money, or money and or time and the speed of something. So rate of change, I feel like, applies more to our real life scenarios. And slope is kind of just the mathematical way of looking at that. So it really is the same idea though. So remember how we talked about the rate of change is the vertical change over the horizontal change when you're looking at a graph? Well, slope is the same thing. It's the vertical change over the horizontal change. And so we like to describe slope as the rise over the run. And the reason is because when we think of the rise, rising is going up and down. And when you're running across a field or the ground or something, you're going horizontally, right? You don't run vertically, you run horizontally. So if you want to write this down or kind of star this, the slope really is equal to the rise, how much something is changing up and down, over how much something is changing left and right, horizontally. So the rise over the run. And so let's take a look at this example. Model cars. Find the slope of a ramp designed to race model cars that rises 6 inches for every horizontal change of 16 inches. So when we're looking at the slope, it's always the vertical over the horizontal change. So if we're starting here at 0 and we're going up to 6 inches and then over to the right 16 inches, then we're really kind of finding the slant of kind of how it gets to this point, going up 6 inches and then to the right 16 inches. So we're going to write this as 6 over 16. The rise is 16, the run is 6, or the rise is 6, the run is 16. And then we always want to simplify our slope. So the slope simplified is 3 over 8. And if you want to write it as a decimal, you can, but we normally just write it as a fraction. So when it comes to a coordinate plane, every line has some type of slope. Either it has a slope or it has no slope. So we're going to take a look at what that looks like. Now in this, when we're looking for a slope of any line, the first thing you need to do is just pick 2 points, okay? And the 2 points that would be the easiest to pick would be a location where it's on the grid in between, kind of crossing between two lines. So like this point here and this point here, 3, 2 and 6, 4, those are great points because those are kind of on the grid where you can count out exactly where it would be. I wouldn't really want to pick a point on the box, like something like right here or right here, right? Because I can't count how much this is. I know that for every line, that's 1, 2, 3. So it's 3 at the X and then up 1, 2, 2 at the Y. So I could maybe use this origin, this point here, 0, 0. That would work, but you want to pick 2 points and relate them to each other. So what you're going to do is pick 2 points and then count out how much is going up to get to the next point, and then how much it's going over to get to the next point. So the rise and the run. So if I look at this, it's almost like I have to stair step up to see, it's going up 1, 2. So the rise is 2, and it's going 1, 2, 3 to the right. So the run is 3. So my slope is 2/3. So now when we look at these fractions, this actually isn't just a number, or a number that has a value, but it actually is a movement. So we see this is going up 2 to the right 3. So this fraction actually explains the movement of the line. Now, let's talk about if a line is going down. So if my line is going down, let's say I use this point and this point, right? I just found 2 cross sections here, and I'm going to count the rise, which rise can go up or down, right? So it's just the vertical. So we're going to count, well, going from this point to this point is going down. So I'm going to go 1, count it, 2, 3, 4, 5, 6, 7, 8, and it's going down 8. So we're going to show that something's going down by using a negative number. Now, if it's going to the right, then that's going towards the positive end. So we're going to use a positive number to show that's going to the right. If it's going to the left, so if my slope kind of went down this way and I was going, counting down 8 and then to the left, then I would use a negative number. So kind of think through your graph. If you're going towards the right, it's going towards the positive side. If it's going up, it's going towards the positive side. But if it's going down, it's becoming negative. If it's going left, it's becoming negative. So it's going to the right 6, and so that's a positive 6. So the rise over run, showing the slope, is negative 8/6. Now when we simplify that, that's negative 4/3. And I like to put my negative kind of on top usually, because that tells me it's going down 4 and then to the right 3. Now, if we count this out, something interesting that you see is any point that's intersecting between on the grid is a point that you could use. So if I counted down 4/3, I would end up at this point here. So if I go down 1, 2, 3, 4 to the right 3, 1, 2, 3. See how I have this point, and then I go down 4, 1, 2, 3, 4 to the right 3, 1, 2, 3. So the slope continually, forever and ever, this line could go forever and ever if I had a bigger graph, right? It is going down 4 to the right 3. Same with this one. The slope that I'm seeing is it's going up 2 to the right 3. So if I start at this point, the origin, it's going up 2, 1, 2 to the right 3, 1, 2, 3. End up at this point. Going up 2, 1, 2 to the right 3, 1, 2, 3, right here. I could try again. Up 2, 1, 2 to the right 3, 1, 2, 3. See how every point that I draw that follows this slope will be on this line. So think about this line goes on forever and ever. It's going to keep following that pattern with that same slope. Okay, so let's look at some example problems here. Number 1, it says, what is the slope of a hill that rises 3 feet for every horizontal change of 12 feet? Write as a fraction in simplest form. So the rise is 3, the run is 12, so it's 3/12, that's the movement, and that is going to be simplified as 1/4. So 1/4 is your answer. We always want to simplify our slope. Number 2, Mr. Watson is building a staircase. What is the slope of the staircase if it rises 20 inches for every horizontal change of 25 inches? So think of your staircase, 20/25, and we simplify this, that would be 4/5. So that is the slope in simplest form. Now we're going to find the slope of these graphs. So number 3, looking at the 2 points, I'm going to count. Well, from this point to this, it's going down 1. So I'm going to use a -1 to show that. And then it's going to the right 1, 2, 3, 4, to right 4. So -1/4 is the slope. Then number 4, going from here, we're going up 1, 2, 3, up 3 to the right 1. So 3/1 is my slope. Number 5, I'm going down 3, or I don't know, I have to count it. 1, 2, 3, 4, and then to the right, 1, 2, 3, 4, 5. So 4, going down 4 to the right 5. So positive 5 there, that's the slope there. Okay, so hopefully that makes sense. Now when we see these fractions, that's just we can see that those are the movements of from point to point to point on a line. Now looking at how to calculate the rate of change. So remember yesterday or the day before when we talked about how to find the rate of change, it's the change of the vertical over the change of the horizontal. Well, really, this is no different. And so instead of finding the final point and the initial point like we did in class, we can now just pick any 2 points and label them as point 1 and point 2, okay? So that is going to be my biggest advice to you. When you find 2 points, label it as point 1 and point 2. So we're gonna look at this example here. I can literally use any points that I want. I know it's kind of blurry, but the study guide picked these 2 points for us. So the point I have is 5, 1 and 9, 4. I would suggest maybe writing out the points on the side. And then what I would do is I would label these points, point 1 and point 2. And the way you're going to do that is you're going to describe this as x1 and y1, because this is all the first point and every point has x and y, right? The second point I would label as x2 and y2, because this is the second point. And you know, every point has x and y, but I'm just going to label them both as 2. Now, if you wanted to switch them around and say that 9, 4 was your x1 and y1, or 5, 1 was your x2 and y2, that's fine too. The actual number of the points doesn't matter so much as you need to make sure that that point itself is 1, 1 and then 2, 2. So if you wanted to make this 1, 1, x1 and y1, and x2 and y2, you totally could. Now I'm going to show you both examples where you get the same answer. So we're going to do this first one first, okay? The way you find the slope, the equation for finding slope is to subtract your y's. So we're going to do y2 minus y1 over x2 minus x1. And you kind of did this already. You just didn't have this equation written out to you. A lot of times, actually all the time in algebra, we use m to represent slope. Okay, so this is the classic equation for finding slope. Y2 minus y1 over x2 minus x1. And the reason why is because y is the change in the vertical and x is the change in the horizontal. So really you're doing the same thing as what you did in the last lesson. Now you just are, I guess, in some way simplifying it, where you're labeling your information and then plugging it into the equation. So using this blue highlighted part, y2 would be 4. So see how I labeled this? Y2 is 4. So I do 4 minus, and then y1 is 1. So I would do 4 minus 1. And then I would have 9 minus 5, because x2 is 9 and x1 is 5. See how I labeled that? And so I'm just replacing what it is, 9 minus 5. And when I subtract and write it out, I have my slope. 4 minus 1 is 3. 9 minus 5 is 4. So my slope is, it's going up 3 to the right 4. And I like using these arrows because it kind of helps me recognize the direction that it's going in. So if I look at my points and I count them out, notice my boxes are going up by 2. So that means it's going up 1, 2, 3, and then going over to the right 4. 1, 2, 3, 4. Okay, yeah, that worked. And I'm counting by half a box because my numbers are 2 numbers per 1 box. Okay, let's use an example where I use the second part where I labeled them just a little bit different. I mean, I just switched the 2 in order, and I labeled my second point as my first point and my first point as my second point. Okay, so these are my points here, and let's see if I get the same thing. I want to show you how it doesn't matter what I label as x1, y1, x2, y2, as long as the 1's are together and the 2's are together, you will get the same answer. So in this case, I would have 1 minus 4 as my y2 minus y1, and then x2 minus x1 is 5 minus 9, so 5 minus 9. Now notice here, 1 minus 4 is negative 3. 5 minus 9 is negative 4. What happens when I have a negative over a negative? Well, it becomes a positive, doesn't it? But if I really wanted to use my negatives to make sense of my graph, then what I have here is it's going down 3, and then to the left 4. It's going down 3 and to the left 4 because it's negative, so it's going down. It's negative here on the run, so it's going to the left. So let's imagine I'm going to follow this pattern, going down 3. 1, 2, 3. And then to the left 4. 1, 2, 3, 4. Oh my goodness, what just happened? My point that follows this pattern is on the line. So I'm going to keep going down 1, 2, 3, and then to the left 4. 1, 2, 3, 4. Guess what? If I follow this pattern, it's still on the line. So see how a negative 3 over a negative 4 is the same thing as a positive 3 over positive 4, because a negative over a negative is just positive. So these two are the same thing, and no matter which, if I follow the direction that this slope tells me to go, or if I follow the direction that this slope tells me to go, my plots are still going to be on the line. So you don't have to worry about so much of like which one you're going to label as 1, which one you're going to label as 2, as long as each point is identified as 1 and 2, okay? So let's practice a little bit. And if we check our answer, it over here on the study guide does say the slope is 3 over 4, right? So that confirms it. Okay, so let's pick a few of these on the bottom. Basically, what you are going to do is you're going to label each point as x1, y1, x2, y2, and then we're going to plug it into the equation and find the slope. So x1, y1, x2, y2. Never label your points as x1, y2. And it's not 1 and 2 as one point. It's the whole point is 1 and the whole point is 2, okay? So now we're gonna plug that in our equation, y2 minus y1 over x2 minus x1. So this will be 4 minus 2 over negative 5 minus 2. So now I have 4 minus 2, which is 2. And this would be negative 5 minus 2 is negative 7. So the slope that I have, it's going up 2 to the left 7. That's my slope. Okay, let's do number 3. x1, y1, x2, y2. Okay, so y2 minus y1, 3 minus negative 4. Don't forget the negative. Over 7 minus 7. Okay, when I look at this, 3 minus negative 4 is positive 7. 7 minus 7 is 0. So what's going on here? This means it's going up 7, but it's not going left or right at all. So let's go back up to these examples here. If you have a slope where it's 0 rise and it's running any number, so this could be 6, this could be 2, could be 5. If you have a 0 over a number, that means it's not going up and down. It's going left and right because there's no rise, but there is a run. That means this is a horizontal line. And so horizontal lines have a slope of 0, okay? That's my horizontal line right here. If you have a slope where it's rising, there's a number in the position of the rise, but there's no run, that means it's going up and down. So 4 over 0, that's going up and down. Now, when we input these slopes, a slope with a horizontal horizontal line is called a line with a slope of 0. And really, if we think about this mathematically in our calculators, if you put 0 divided by 6, your answer is going to be 0. Now, a vertical line, we call it an undefined slope. So The reason is because if you put 4 divided by 0, you say, I have 4 cookies and I'm going to divide it amongst 0 people. How many cookies are each person going to have? Well, that's not a thing because you have no people, so you can't divide. So a number divided by 0 is what we call undefined. And if you plug this in your calculator is going to say error. And so you can try that. Plug it in your calculator. A number divided by 0. Your calculator is going to say error. And because of this error, we call this line undefined. And so I like to think of it, whereas horizontally, you physically can run horizontally. So we're just going to say, oh, okay, this slope, there's no hill, it's just consistently horizontal. But can you run vertically? Are you physically able to run vertically? No, you can't. It's impossible. So you're going to say that that line is undefined. So when we come down to this, we have a vertical line here. So think about what's the movement going on. Well, it's going up and down, going up 7, but it's not going left and right. So this is a vertical line, and we're going to say it's undefined. Okay, so that's kind of a tricky thing to remember because, you know, that's different from just looking at the slope. A little throwing that in there for you, but that's undefined. So it's undefined slope. Okay, looking at number 4. So number 4, we're going to label our points x1, y1, x2, y2. So y2 is 3, y1 is 9, so it's 3 minus 9 over negative 5 minus 3. So when I subtract, I have a negative 6. And then negative 5 minus negative 3, add the opposite, is negative 8. Can I simplify this? Yes, I can. And it's a negative over a negative. So when you have a negative over a negative, you can just write it as a positive. And so this would be 3 over 4. Right? Divide that by 2. So it has a 3 over 4 slope, which means it's going up 3 to the right 4. Okay, let's do number 8. x1, y1, x2, y2. So 3 minus 5 over, not 3, negative 3, right? Don't want to forget my negative. Negative 3 minus 5 over negative 6 minus 2. So if I add the opposite, I have negative 8 over negative 8. And when I simplify this, it's just 1 over 1. So my slope is going up 1 to the right 1. Or if I wanted to say negative 1 over negative 1, it's going down 1 to the left 1. Okay, I think you get the idea. So you can do the rest of those if you want to, see what slopes you get. You can graph them out just to practice, but that's all I have for you today.